In this video, we are going to learn orchestration-based implementation of the SAGA pattern. Orchestration-based implementation of the SAGA pattern involves using a central orchestrator service to coordinate and manage the individual SAGAs or microservices that makes up a transaction. In this approach, the orchestrator is responsible for initiating the transaction and ensuring that each SAGA performs its step in the correct order. If any of the SAGAs are failed to complete their step, the orchestrator can use the compensating transactions to roll back the change and restore the system to its original state. So orchestration provides to coordinate SAGAs with a centralized controller microservice. This centralized controller microservice orchestrates the SAGA workflow and invoke to execute local microservice transactions in sequentially. The orchestrator microservice executes SAGA implementation and SAGA transaction and manages them in centralized way, and if one of the steps is failed, then executes rollback steps with compensating transactions. Here you can see the image shows that a failed transaction with a SAGA pattern. The update inventory operation has failed in the inventory microservices. So when it failed to one step, the SAGA invokes a set of compensating transactions to roll back the inventory operation, cancel the payment and the order, and return the data for each microservices back to a consistent state. All these coordination and these operation managed by the centralized orchestrator, which is the centralized controller microservices, which is the SAGA orchestrator. Now we can see the benefits and drawbacks of using orchestration based SAGA implementation. Let me start with the benefits. The main advantage of this approach is to provide a clear and centralized point of control for managing transactions. This can make it easier to understand and debug the system, and easy to add new transactions or modify existing ones. But it comes with the drawbacks. However, the orchestrator can also become a single point of failure, and if it goes down, the entire system may be unable to complete these transactions. Additionally, the orchestrator can become a bottleneck if the system is heavily loaded, as all the transactions must go through it. So that's why we should be careful about that. As a result, we can say that the orchestration based implementation of SAGA pattern can be a useful approach for managing transactions in a distributed system, but it is important to carefully consider the trade-offs and potential drawbacks. So orchestration way is good for the complex workflows, which includes lots of steps, but this makes single point of failure with centralized controller microservices and need to implementation of complex systems.